Hi everyone, my name is Mohan. I'm a freelance advisory consultant focused on blockchain, AI, and business and technology transformation. I built this demo to experiment and explore vibe coding. And in this exercise, I used Gemini, Claude, Grok to figure out how they all assist in writing code and solutions. I chose healthcare claims processing as a continuation of my earlier post, mainly because managing supplier risk in healthcare supply chain talks about claims processing, and I presented it at the Conv 2X last year. This year, I speak again at Conv 2X, which is going to be held in Cambridge, Massachusetts on September 25th and 26th. So it made normal sense for me to choose the topic and the use case. Before I proceed further, I do want to say that a lot of my experience with architecture, business process knowledge, and design patterns really came handy when interacting with these assistants to do vibe coding. So that really was very helpful. Let me go into the demo and share with you what I have done. So the first thing I want to do is get into the VS Code environment, which is the IDE that I used. The Most of the code here that you see on the left, the Python programs have been generated using the assistants. Most of it was generated by Gemini, and then later on, as Gemini started to falter, I utilized both Claude for some of the claims processing modules, and for the rest of it, including the blockchain aspects, I used Grok. Now, Grok was really very helpful in figuring out incompatibilities with libraries that were there, as well as versions. And it also incorporated errors into the logic wherever it was missing. The main program here is AppFresh. It is written in Streamlit, which is the UI library that I have used. Streamlit fires off the main UI where patient's entry can be done or even updated. And it also connects to the rest of the modules here. You can see there is a blockchain logger, which logs events into the blockchain, a chat module that connects with the LMs to initiate chat request responses. We have the claims module that generates the 834p claims formatted EDI files and also gets them verified. And then, of course, we have the viewer. There's also one interesting file. It's called LLM utils. This is where the LLM of choice is initialized, and then it helps us in passing the request and retrieving the responses for the queries that go through the solution. There are many other files here, such as prompt .py to help with React and one-shot as well as multi-shot prompts. There is the requirements.txt that includes all the libraries that need to be installed, and setup files and several other files. So we won't bother about those too much here. I also used a vector database. In our case, initially I used Chroma and later on FAISS. Now, the vector database was loaded with these documents, these PDFs, essentially 837p COM guide, the annual update to the list of CPD codes and other codes, ICD 10, October 2025, so many other things. Now, these were embeddings were created and loaded into the vector database, which you will see. Now, before we fire up the application, let's get in and see how I'm using the blockchain. For our purpose, I'm using Ganache. Ganache was used because it's installable locally. When Ganache fires up, it gives you a set of accounts and private keys. I have used the first private key and the first account that you see on the screen for the application. Let us fire the application up. It's a Streamlit application. I'm going to run it and ask it to fire up appfresh.py. When the application loads, it brings up the initial screen. The initial screen is about the patient registration information as well as capturing patient visit information. Now, before we do that, we have to initialize the settings. For the purpose of studying and exploring, I have three different LLMs that one can pick from. Here we will pick Claude as our LLM, and we can also set the accuracy or the levels for the temperature and the top piece settings. This helps us to make the responses more deterministic. Once we initialize the LMs, we can also go and initialize the vector database. As I pointed out, we have already loaded some PDFs embeddings into the database. So this is simply initializing the database and getting the existing knowledge. But as we learn more, for example, if a doctor or a coder or a biller learns more, they can actually have additional documents that can be processed through this over time. Once the initialization is complete, we can go and explore how it works. So rather than go and enter all the data, let's load something that is already existing. I'm going to choose a test patient here, Susan Smith. Once we load, Susan is the subscriber here. And you can see Susan's information first, followed by the patient information. And we have Jack as the patient, and Jack's billing information is here. Most of the data that is here is test data. Some of it may be legitimate, but others are all test. And of course, one can add visits. Um, After the first visit, every visit is a follow-up visit. If we expand the diagnostic details for coding, it opens up a window for capturing the details. I have some predefined details here, which I can pull in. We'll copy this into the chief complaint. And there is some historic information as well in this area. Now, obviously, this was based on some looking at examples and studies here and there. The next part, we can fill in the available physical and system analysis. The third portion captures the patient's assessment, and the last portion captures the code as determined by whoever is filling these entries. There are a bunch of codes that were determined here. Let's take the code and then let us change this a bit for our purpose. And the plan is here for treatment. Once we have this, we can use AI to help us. There are two ways in which AI has been configured here. One is either to verify the code that has been entered, or one is to help us look for a code. In this ICD case, let us say, help me to verify the code that has been entered. Well, it determines that the correct code is what has been shown on the screen. So we will correct it to that. There may be discrepancy. And in the second case, like the CPD code, let's go and request it to search for the code. The code that was determined is 99214. I do not know what that means, but let's take its word for it. And we finally fill up some charges for the visit, add the visit to the list. And once there are many visits here, because I've tried this application so many times, and the patient's bill is also rising. But now let me save all the patient data here. So we used the AI for two purposes here. One is to search and one is to verify, but in reality, one could use all these visits as part of an AI agent to look across and see what kind of issues the patient has had and what kind of treatments and treatments were planned in the past. So that's an opportunity here. Now that we are done with this, let us see if we can generate a claim. Now for the claim, I would like to use another patient. In this case, I would like to use patient Mohan. The reason we are choosing this patient is because of some of the entries that are legitimate for the generation of a claim, like the subscriber ID. They are all in the right format and semantically and structurally, including the patient's insurance ID and some of the billing details like the van ID, the EDI information, the NPI information are all very legitimate values. So let's go and generate a claim for this patient. Choose Mohan and then generate the claim. Now the claim is generated and it is also saved in a file. It then passes this generated claim to the AI to figure out whether it is structurally and semantically correct. In the past, the way I tried to generate the claim was by passing the data to the LLM directly and get the claim. But then upon verification with a verifier, I noticed there are segment errors, especially some LLMs showed more segmentation errors than others. The best one that really had the least amount of errors was Claude. So I changed the design approach here to generate it the traditional rule-based way and then pass the claim to an LM for verification. And the verification report is on the screen. We can scroll down and we can even save it for future analysis purposes using AI. The EDI that is also generated can be copied to a clipboard and used elsewhere. In this case, I would like to use the generated EDI to see if it is structurally and semantically correct. So I have an EDI verifier, which is open source, and I plug this value in. And then I say, parse it and show me in human readable form what does the EDI say. And of course, the EDI essentially tells us that this is the information about the patient, control number, and so on. I could potentially pull the patient up here, or we could look at a patient, which is Mohan. And we can see it's Mohan, the address, Cibola Drive. There is other details here, including the van information and other things. So if we go back and see, that has all been codified into the EDI and then passed on, including key insurance, address of the key insurance company, and so on. So that's the purpose. Let's move on further and now try to look at, we can either submit the claim, but that is not implemented yet. We could potentially go and view blockchain logs. The blockchain captures all the events that are generated and are requested to be saved by the blockchain for purposes of audit and future proving of the accuracy of the data that was used or processed. Whatever the purpose may be, but the blockchain has recorded all the events that have just occurred, like a claim was viewed or was it processed. It's in the order of time. And of course, the claim was generated, so we can see all the events that were generated has been recorded on the chain. If we switch back to the blockchain screen, potentially we can see these transactions are getting logged one after the other. This was the last block that was created on Saturday at 2:47. So they are getting locked based on what events were submitted. Now that concludes our demo. I hope you all enjoyed it. If you do like the demo and you want to help use my help, please feel free to email me at mohanv@outlook.com or reach out to me on LinkedIn. Thank you, and you all have a wonderful day. Bye bye.